Solving linear equations by substitution. What does that mean? We're going to find the solution of two equations by another method of evaluating. Meaning I'm going to show you how to take a piece of one linear equation, substitute it into another to find out the solution. Remember, the solution is x and y. One key trick I want you to think about while we're doing this is when you look at the equations, you want to choose the one that's the easiest to isolate. Maybe it's already isolated. What do I mean by that? Take a look right here. Y equals x plus 2. The y is already isolated here. That would be a great one to use to substitute automatically, and then we can find out the solution. X plus y equals 2. If I had those as my choices, I can use inverse operations and I can isolate x very easily, or I can isolate y very easily. X equals y, direct variation, already done. X equals -3, again, already done. Over here would be a little more difficult. 2x plus 3y equals 6 would be a little more difficult, little more work there to isolate either y or x. So, example 1. Equation 1 says -x plus y equals 1, and equation 2 says 2x plus y equals -2. Solve the linear system by substitution. Step 1, I decided I'm going to choose the -x plus y equals 1 to isolate the variable for that one first. That's easier for me. All I got to do is use inverse operations on the -x, and instantly I have y equals x plus 1. Now I'm going to take this x plus 1 and I'm going to substitute it into the other equation. Substitute x plus 1 for y in equation number 2, which is this one, and find the value of x. So I take this equation right here, 2x plus y, 2x plus, and I'm going to insert that in for y, x plus 1 equals -2. Combine like terms right here. I get 3x plus 1 equals -2. And now I'm going to use inverse operations. And I've got 3x equals -3. Inverse operations again on the coefficient here, on both sides. And I've got x equals -1. So now I've got x equals -1 as part of that xy solution that I'm looking for. I'm not done yet. Step 3. Substitute the -1 that we just found out into equation 1 and solve for y. So this was equation 1, the original. Y equals x plus 1. I take the -1 and I put it in there for x. And I find out that y is 0. So now I have my xy, which is going to be -1 and 0, x and y. And I'm going to, step 4 is checking it out. I'm going to put those into each equation and evaluate. Equation 1. Y equals x plus 1. I just insert 0 for y, -1 for x, and I work it out. And I do in fact find out that 0 equals 0, and we're in good shape. So far so good. Equation number 2. 2x plus y equals -2. This was the original equation. Plug this in, -1 and 0. -1 for x, 0 for y. Work it out, and in fact, we're a happy camper again. Great stuff. Let's try another example. Example 2. Equation number 1, 2x plus 2y equals 3. Equation number 2, x minus 4y equals -1. Remember, step 1, I want to find the easiest one to isolate first. And so I look at this And I love it when I don't have a coefficient that I can see in front of one of these. So we're going to solve for x first. How do I do that? Quickly just inverse operations on the negative 4y right here, both sides, and I find out that x equals 4y minus 1. Now I take the 4y minus 1 and I'm going to substitute it in equation number 1, remember, equation number 1, and find y. Take this, write it over again by substituting 4y in for the x. And as I work this out, 2, I distribute property right here, 2 times 4y minus 1, I get 8y minus 2 plus 2y equals 3. Take this little arrow, follow the path right here. Combine like terms, 8y and 2y, I get 10y minus 2 equals 3. Inverse operation here. All I'm doing now is I'm solving for y. I'm isolating y all the way through. We're left with 10y equals 5. And divide both sides by 10. Y is 1/2, way over here. Y equals 1/2. That was step 2. Step 3, take the 1/2 that we just found out for y and put it into the revised equation number 2 to find x. Which one was the revised equation for number 2? It looked like this. X equals 4y minus 1. Remember, we took this 4y minus 1 and substitute that in earlier into the other equation. So now we're going to take 1/2, insert it for y, work it out. 4 times 1/2 is 2, and we get x equals 1. Now we have it. Now we have our x and our y, and we can take this and we're going to put it into our equations, our original equations, and see if we have a solution for our system of equations. Verify 1 and 1/2, x and y, is a solution. Equation 1, I take these and I substitute them in there. And if I do the work correctly, I will find out that yes, in fact, that checks out. Equation number 2, this was the original equation, number 2. X minus 4y equals -1. I take my solution, x and y, plug them in, work them out, and -1 will equal -1 through there.